Okay, we have here today another interesting integral from the Berkeley integration bee 2020. This one was problem number 5. We have the integral from 0 to 1 of ln x times sine ln x dx. Okay, and you may notice I actually did this problem not very long ago at all, maybe a couple of weeks ago. And the reason I'm doing it again was there was an interesting suggestion in the comments to try this using Laplace transforms. And when I did it with Laplace transforms, I actually found it was quite a bit quicker, but also it was interesting because I don't think I've done a problem like that in the past on this channel. So before we get to any Laplace transforms, we need to do a substitution. It's just a slightly different substitution than what we did originally. I'm going to make my substitution for x equals e to the minus t, where in the first time when I did it, I think my substitution was just e to the u, which when we transform this by taking natural log on both sides, we could write this as minus t equals natural log of x, or t equals minus natural log of x. And then I'll take my derivative right here to get our dx value. So dx is just going to be minus e to the minus t dt, and we'll go ahead with this substitution. So first, let's just do the bound. So we'll plug a 1, we'll use this one, I think. No, we'll use this one, sorry. So I'll plug a 1 in here, and we'll have 0 for the upper bound. And I'll plug a 0 in here. Natural log of 0 is going to minus infinity, but we have a minus in front, so this is actually going to be just infinity. Our value for natural log of x is going to be a minus t right here. Then this is going to become sine of minus t. And our dx value, again, just keeping track of all these minus signs, we're going to have minus e to the minus t dt. Now, because sine is odd, I can take this minus sign here out front, right? And we'll cancel that there. But then here I have minus times minus, so let's just multiply those together and turn those into plus signs. And then with this minus sign, what I'm going to do is take it out front, and we'll use this minus sign just to swap our bounds around so that we'll have this going now from 0 to infinity. Okay, now after cleaning this up, you may notice this integral right now is in exactly the right form for the Laplace transform. Okay, now at this point you'll notice that we have our formula for the Laplace transform over here on the right. Now I'm not going to go too deep into this, but I will give enough information so that we can do this problem. You'll notice for the Laplace transform we have this curly L kind of symbol that we use for Laplace transform, but it's just an integral in this form. So it's just kind of a shorthand we have for this integral. And the kind of interesting thing about it though is we have, notice everything's in t, but we have this parameter s. And the way this works is the result of this is actually going to be a function in s. Now getting back to our problem, you'll notice the similarity here. Notice we have the same exact bounds here going from 0 to infinity. Now we have the e to the minus t. We don't have the s, but if you just think about it, if we just kind of draw in an s here and you consider this, we can do this as if s equals 1, then we're fine. But by creating an s value equal to 1, then we haven't changed it and we're in the exact right form of our Laplace transform. And then again, we need some function f of t. Well, our f of t for this is going to be just this t sine of t. So using the Laplace transform and just comparing with this, what we're actually trying to find here is just the Laplace of this f of t, which is going to be t sine of t. And the nice thing about that is a lot of Laplace transforms are not very hard to calculate, or we kind of just memorize values from a table so they can be done pretty quick. Now, one thing that's going to make it a little more tricky is we actually have two different things here. Like if it was just sine t or if it was just t, this would be very simple, but we have both. Now, there is a specific formula for the Laplace transform of t times some function. So let's just look at that formula right now. So the formula we're going to use for the Laplace of t times some function g of t, where g of t is just going to be our sine t. So in order to find this value, what we're going to need to do is find minus 1 times the derivative of this g of s function. Well, this capital G here is just a way to indicate that we're looking for the Laplace of g of t. So what we want there is we're going to want the Laplace of g of t, which is sine t. So we just need to find the Laplace of sine of t. And notice it's going to be a function in s. Well, this is a really common formula. The Laplace of sine of t is just going to be 1 over s squared plus 1. And I think what I'm going to do is I need to take derivative. I'm going to write this as s squared plus 1 to the minus 1, just so I can use the power rule on it. And then over here, we're going to need the derivative. So I'm going to need minus. The derivative of this is going to be, we'll just use power rule. It's going to be minus 1 times s squared plus 1 minus 2. And then we're going to need the chain rule and what's inside, which is just going to give me 2s. Minus times minus here is going to cancel and just be a plus. And so I can write this here as 2s over s squared plus 1 all squared. Okay, so now at this point we have a solution, but it's in terms of s, because like I said earlier, the Laplace transform, what it outputs is a function in terms of s. So what we need to do here is just go back to the original problem and realize that we inserted this s that we didn't have in the problem. We just created it and we called it 1. All we're going to need to do is plug in 1 here in order to finish this off. So let's just do that. We'll plug in 1. We're going to have 2 times 1 in the numerator. And then here we're going to have 1 squared plus 1 all squared. This is going to give me just 2 over 4 or 1 over 2. And thankfully, that's the same solution we found in the other video. Again, if you're new to Laplace transforms, it kind of takes some getting used to, but just keep in mind when you actually do these, you usually have a table of formulas that you can reference or that you memorize. And so we really just use 2 formulas. We used the formula for t times something to use the derivative, and then we just needed the formula for the Laplace of sine of t. So if you want some more information on the Laplace transform, I'm sure I'll do some videos in the future. Also, I have a few things on my website. So on the website, I have a cheat sheet with a table of all these kind of formulas that you can use. That's really handy. And also I have a couple of quizzes if you want to check that out. So we'll stop it there. Thanks everyone for watching. Have a great day.